So this is the teacher and these are her students. She wants to divide students into group of the same size. First, she tried group of 3 students and there's 1 left. So she's like, I'll do group of 4 and now there are 2 left. She was annoyed. So she tried to divide them into group of 7 and now there are 4 left. So the question is, how many students are there in her class? What's up everyone? Thank you for spending a little bit of your time with me today. And if this is your first time here, please subscribe so you'll not miss my next video. So today we're gonna be answering this question. Let's say you have a number n, say it's a number of students in your class, and you want to divide them into group of even size. So you try group of 3, there's 1 left. You try group of 4, there are 2 left. You try group of 7, there are 4 left. And you wonder, how many students are there in your class? So first, this question can be rephrased using mathematics language as follows. So it goes like this. You want to find number n such that when you divide n by 3, you have a remainder and the remainder is 1. Divide n by 4, remainder is 2, and divide n by 7, remainder is 4. Notation-wise, this question can be rephrased using modular arithmetic. If you don't know what modular arithmetic is, then it's okay. I'll mention here once and I'll not use it again. It goes like n congruent to 1 mod 3, n congruent to 2 mod 4, and n congruent to 4 mod 7. So the theorem behind solving this problem is called Chinese Remainder Theorem. However, the theorem just says this problem has a solution. Well, it actually tells you a little more. It tells you that there are infinitely many solutions and how to find all of them if you know one solution. But the important part is it doesn't tell you how to find one solution, which is not what we want from this problem. We want to find a solution. So here I introduce the algorithm behind Chinese Remainder Theorem. Alright, so before I go over how to find the n, let me tell you one key concept that we'll be using over and over, and it as follows. If you have number n, which is the sum of 2 numbers a and b, and the special thing about this situation is you know further that a divisible by 5. What you can conclude is that remainder of n and remainder of b, when they are divided by 5, are the same. Right, so this statement is pretty convincing as a divisible by 5, so a can be divided to group of 5 evenly. So remainder of n has no contribution from a. So all remainder of n come from b. Right, so the reason that this problem is hard because 3 conditions that we ask has some interaction between each other. So imagine that somehow you come up with n that satisfies first and second condition, but not third. Then there's no obvious way how to modify that number that you know satisfy first 2 conditions, so it satisfies the third one as well without ruining the first 2 conditions. In some sense, this is almost like Rubik's Cube kind of problem that suppose somehow you solve 4 of the 6 sides of Rubik's Cube already and you have 2 remaining. Then there's no obvious way how you fix those 2 sides without ruining the other 4 that you solve already. And here how we fix that. We guess the form of n to be like this. Alright, so it goes like this. You write n as a times 3 times 4, b times 4 times 7, and c times 3 times 7. Alright, this is nice. Why is this nice? Well, let's look at 3 conditions that we want n to satisfy. So let's look at what happens when divide n by 3. So note that this term and this term are divisible by 3. So by our main observation, remainder of n is the same as remainder of this term when divided by 3. Alright, so that's what we have. Remainder of n and remainder of b times 4 times 7 are exactly the same when you divided both terms by 3. Alright, likewise, you can do this with 2 other conditions, meaning you can look at what happens when you divide n by 4 and what happens when you divide n by 7. Divide n by 4, this divisible by 4, this guy divisible by 4, so remainder will solely depend on this guy. And for 7, remainder will solely depend on this guy. 3 conditions that we originally asked can be rephrased as follows. First condition is when we divide 4 times b times 7 by 3, we want remainder to be 1. You divide 3 times 7 times c by 4, remainder is 2. And then when you divide 3 times 4 from a by 7, remainder is 4. If we somehow can come up with a, b, c that satisfy these 3 conditions, you can just plug this in this formula, then n will satisfy 3 original conditions that we want. Alright, for the next step, let's look at our new first condition. We want to divide 4 times 7 times b, which is 28b, by 3, and we want the remainder to be 1. Note that 28b can be broken to 27b plus b. And again, this guy is divisible by 3, so remainder when divided this guy by 3 is the same as remainder when divided this guy by 3. Alright, so instead of looking at 28b, we can look at b and ask what is the b that make remainder equal to 1 when divided by 3. And likewise, it's the same for other 2 conditions. For the second condition, we have 7 times 3 times c, which is 21c. We want to divide this guy by 4. So we have 20c plus c. And this guy divisible by 4, so remainder is solely dependent on c. And for the last one, we want to divide 3 times 4 times a, or 12a by 7. So we take out 7a and then leave 5a alone. Since this guy is divisible by 7, remainder of the whole thing when divided by 7 solely depend on 5a. And that 3 condition can be rewritten as follows. Remainder of b when divided by 3 is 1. Remainder of c divided by 4 is 2. And remainder of 5a when divided by 7 is 4. Alright, and this is a great place to just do guess and check. Meaning we just come up with b, c, and a that make these 3 conditions true. There's a little more efficient algorithm on how to find a, b, and c. For the time being, we just gonna use guess and check because it's not too much troublesome to do guess and check. For example, if you want b that you divide b by 3, you has remainder 1, you can guess b could be 1. The same for c. You want c to be divided by 4, has remainder 2, so c could be 2. For a, it's a little tricky, but you can just try a bunch of value. You plug in 1, doesn't work. You plug in 2, doesn't work. You plug in 3, doesn't work. You plug in 4, doesn't work. You plug in 5. 5 times 5 is 25. Divide by 7, you get 3 with remainder 4. So 5 work. With this, we can just plug a, b, c back into the formula for a. So we get 60 plus 28, 42, which sum up to be 130. Alright, so here you have it. 130 is a correct answer. It's not the only answer. Turns out there are infinitely many answers, and the way to get all the answers is just add or subtract by 3 times 4 times 7. And you can do this as many times as you like. Why is it true? Well, the reason is 3 times 4 times 7 is a number that divisible by 3, 4, and 7. So adding this number will not change the remainder when you divided this guy by 3, 4, nor 7. So you're adding 3 times 4 times 7, those 3 conditions will remain true. And in fact, this will give you the smallest possible answer, which is 130 minus this guy. So now to be 84, so the difference is 46. And this turned out to be the smallest possible answer. So back to original question, how many students are there in that class? The answer is we don't know because there are infinitely many possible answers. The smallest one is 46, the next one up is 130. So if you were to guess, then the answer should be 140 because 130 is pretty big, and who would teach class with 130 students? And all other answer will be 130 plus 84, 130 plus twice of 84, so on and so forth. Alright, so that's all I want to talk about today. If you have any questions, please make sure you leave comment down below. And if you haven't done so already, please subscribe so you not miss my next video. For today, thank you for watching. My name is Kwang and this is N Choose K. Peace!